with some answers. So, am I correct? I showed you guys 1 and 2 last time, right? Yeah. Okay. So, number 3. So, with a question like number 3, strongly encourage you to notice this because you could get yourself into a very confused place. If you started thinking about natural logs and flip ups and all that stuff, what do you need to notice that will give you good direction on number 3?
Division.
Degree. Yeah, if you look at the degrees, that'll lead you to division because if the degree of the numerator is bigger than the degree of the denominator, consider division. And did you guys all do synthetic? And you don't have to. You can do long division. It would look like this. Whoa. These numbers get a little bit large, don't they? You guys get that for your division?
Yes.
So, whatever. Numbers are a little bit big. So then you'd get integral of x squared plus 12x plus 45 plus 182 over x minus 4 dx. Of course, it's really easy at this point to think that you're done because you did do something, right? You did an important thing, but you haven't found any antiderivatives yet. Now we're just going to go through and use the appropriate rule, giving you 1/3 x cubed plus 6x squared plus 45x. And what's the last term? That's a natural log, yes. So it'd be plus 182 natural log absolute value x minus 4 plus c. Any questions? You guys good? Okay. Number 4. Did you guys notice that number 4 looks an awful lot like number 2? In fact, they are identical except the numerator is x versus a 2. In number 2, it was an arctan. In number 4, did you guys see that it's not an arctan? Do you see how I tried to make it look like one? Yeah. It really does look like one, except the numerator is off. So here's what I would encourage you to do. Always follow that system that we talked about. As long as the degree of the numerator is less than the degree of the denominator, this should guide you in the right place. So first is it natural log? And the question you're really asking is the derivative of the denominator the numerator? It's pretty close, isn't it? The derivative of the denominator is 8x. The top is x. So this is a fairly simple, Timmy messed it up, right? So what I'm going to do is I'm going to fix this. So the answer is yes, it's ln. So I'm going to multiply the top by 8. And I'm allowed to do that as long as I multiply the outside by 1/8. Okay, so I've balanced it out. What this means then, since it is an ln, it would be 1/8 natural log of the denominator. There's really no need for me to put absolute values here. Why don't I have to put absolute values? Yeah, there's no way that 9 plus 4x squared could be negative. At least not with real numbers. Question, Colin. Why couldn't it be arctan? Okay, so let's look at it from that perspective. So let's say we came. Were you thinking maybe arctangent of 2x over 3 with maybe like 1/6? Okay. So I should be able to then take that and differentiate it and get the same thing that I started with for my integrand. So if that's the case, this is my u. I'll put it like this. This is my u, this is my a, right? Okay, so if I was going to take that and differentiate it, I'd get 1/6 times. So for arctangent, it's u prime a over a squared plus u squared. So u prime is 2, a is 3, over a squared plus u squared. It's pretty darn close, isn't it?
You just changed the formula.
Wouldn't that be nice? Hey, I just made up my own, and it must be right based on me making it my own. You can see it doesn't match, right? We're off by a factor of x. And this illustrates the issue of, as close as this does look like it is to arctangent, it's actually miles away because it really is ln, which is very different from arctan. X is unfortunately very different than 1. 1x is not 1, only if x is 1. All right, hey, Colin, thank you for asking. It's a good question. Anybody else? Question, comment, concern? All right. So then number 5. So let's do the same thing with number 5. I think that it's valuable to say, hey, is it ln? Is it flip up? Is it arctan? Is it arcsine? All that stuff. Bless you. Clearly you can see the degree of the numerator is less than the degree of the denominator, so no division needed here. So I can ask myself, is it natural log? And the answer to that question is an emphatic no, because the derivative of the denominator is 2x plus 6. The numerator is a 7. We got too many terms. We got an extra x. It is definitely not natural log. Is it flip up? Why would it not be flip up? Say again? Right. Creates the 0 in the denominator issue. Yeah. There's all kinds of like really terrible things. Should I show you? Check this out. Have you ever seen anything so horrifying? Or some other variation on that? Someone hates math. Like, not in that they don't like it, they have like a personal hatred towards math. Trying to like break all the rules all in one shot. Anyway, it's not flip up, because the whole dividing by 0 thing would be a good reason for that. So you're left with arcsine or arctangent at this point, and if you look at that, it's not really either one of those two forms. Which of the ones between arcsine and arctangent, which of one are you confident that it is not? What's missing? Square root. Missing a square root. So it's not arcsine. It must be arctan. But then again, when you look at this, you're like, that does not fit the arctan form at all. The experienced among us knows we need to do what? Complete the square. Yeah, you started to describe what to do. It's called completing the square. So I'll do this off to the side. So it's going to be x squared plus 6x. You guys remember how to do this? Group the first two. Add 9, right? The half of 6 squared is 9. And then you subtract 9. So then we end up with x plus 3 squared plus 4 when you factor the trinomial. Okay, so this gives us this. And getting the 7 out of there, I'm left with my my square completed version. I get that right there. So this looks a lot more like arctan, right? U prime a over a squared plus u squared. So the numerator needs to be u prime a. So the numerator is wrong, isn't it? What does it need to be? 2. Because a isn't a 2? And isn't u equal to x plus 3? So then u prime would be 1. Of course, a is 2. And the numerator, for it to be the right form, needs to be u prime times a. So I need to go times 2. So this is Timmy and his perpetual messing up. Multiply the top by 2, divide the outside by 2 to get the expression balanced. This leads me to a final answer of 7 over 2 times arctan of x plus 3 over 2 plus c. So look at what you have, look at what I have. Question, Dylan?
I'm wondering, is it okay? We did it a different way. We tried to split up the denominator into 7 over x squared plus 7 over 6x. No? That doesn't work.
Why doesn't it work? I did it that way, but...
So we actually were talking about that back there. So it's 7 over x squared plus 6x plus 13. So the proposal was, could we rewrite this as 7 over x squared plus 7 over 6x plus 7 over 13? So if you could do that, then shouldn't I be able to put it back together? Like if you can take it apart, you should be able to put it back together. To put it back together, don't I need a common denominator? Which would be 78x squared, right? And so then I'd have I'd have to multiply 7 by 78, right? You see it now, right? So Jaden said it really well back there earlier. He said you can split numerators apart. Can't do it to denominators. So this is bad. Make sense? Aren't you glad we're doing this? I mean, this like exposes lots of good things and bad things and common mess ups and common good things, hopefully. Questions? Come on. Anything? All right. Number 6. Number 6 is one of the more straightforward ones, I would say. The first thing maybe you would do with number 6 is just get the 6 out of the numerator and outside here. But then, let's go through our kind of our process. Is this ln? I heard a yup and a nope. Anybody else want to weigh in? Why is it not ln? And what's the one symbol that really messes it up? Square root. Yeah. And the fact that it's x squared makes a difference too. Square root is a big factor in there as well. So it is definitely not natural log. Is it flip up? If it was flip up, it'd be something like this. Is it flip up?
No.
Why is it not flip up?
You're off by a factor of x.
Yes, we're off by a factor of x because the derivative of the inside involves negative 18x. The other factor is just a 1 or a 6, depending on how you want to look at it. So it's not flip up. So that's out. This leaves us with just 2 options at this point, one of which makes more sense than the other. Arctangent, arcsine, which one makes more sense? Because of the square root. Okay, so then A would have to be 5. U would have to be 3x. U prime would have to be 3. So in order for this truly to be arcsine, the numerator has to be u prime. And right now, my numerator is a 1. It's supposed to be a 3. It's an easy fix, right? So I'm just going to go times 3 divided by 3. This will give me 2 arcsine of 3x over 5 plus c. How are we doing? Again, look at what you have, look at what I have. If there's like a massive difference or even a tiny difference, let's talk.
Is arcsine technically the same as negative arccosine?
What is
Is no.
other than a negative?
Are you asking me this? Are you saying is literally arcsine of x equal negative arc cosine? For their derivatives, yeah. But arc cosine is considering adjacent over hypotenuse, whereas sine is considering opposite over hypotenuse. Right? So like arc sine, there will be certain angles where that's true. But like arc sine of, like 1 over root 3 is not just the opposite of arc cosine of 1 over root 3. I see where you're getting at that, but we're talking about derivatives versus y values. They're just different. No, you can investigate it more. I don't think so. Other than maybe some specific unit circle angles, I don't think it's right.
So for the derivative of arc cosine, would we identify it like in that problem if it was -6? Would we just take the 6 out?
Well, I would say yes, but I don't think we're ever really going to do that. I think like if this was like some multiple choice, there's no way arc cosine would be the correct option.
Okay.
It wouldn't even be in there. I don't know. That's just a customary
So we
thing.
take derivatives of arc cosines, not necessarily the integrals of
Yeah,
them?
like I've never seen it show up on an AP test
Okay.
because they do just differ by a minus sign. Their derivatives do.
Uh-huh.
So you can get to the thing that you need to get to with either arctangent or arcsine.
Mhm.
And the other ones are there because that's what they are, but they just never show up in at least what they assess. So yeah, Dylan.
So let's do a little bit more of that. Say you multiplied the top by -3 and divided the outside by -3. Then wouldn't you have -2 arc cosine of 3x over 5?
You're saying instead of +3, -3?
Yeah.
Sure.
So wouldn't that kind of say that negative arc or arc sine is equivalent to negative arc cosine? because it would be the same thing as saying.
I'll have to think about that. Think about that. I don't know. It's a good question. I will try to find some time to think about that. It's not as easy as you might think, but I will consider. I'm sure there is a good answer. Okay, number 7. The degrees are what they are, and they're a little bit larger than what we're used to. It's clearly not ln because the derivative of the bottom is way too high of a degree for the top. Flipping up would cause the division by 0. So it's got to be arcsine or arctangent. Which is it not? Because there's no square root, right? So this is going to work out. That means my u would have to be 3x cubed, right? And my a would have to be 7. And my u prime then would have to be 9x squared. So obviously the denominator is set up nicely. Can we make the numerator fit? We're off by a little bit, aren't we? We're off by a factor of 63. So I'd go times 63 times 1/63. So it'd be 1/63 arctan of 3x cubed over 7 plus c. What do you guys think? Questions, concerns? Okay. Right. What did I really try hard to do with number 8? Make it look like what? Make it confusing. What did I try to make it look like, but it's not? I tried to make it look like arcsine, right? Because you look at that denominator and you're like, oh, square root. Maybe it's arcsine. You look a little closer and you're like, oh, 100, that's a perfect square. 36x squared, that's another perfect square. It should all work out nicely except for what? It doesn't. Because of the x. Yeah, the x is what messes it up. So, again, this is just an encouragement to you to hit the brakes and not just race ahead to the thing that it just like immediately looks like. Consider natural log. Is it natural log? No. It's not. What's the one symbol really that messes that up? Square root. The square root. Yep. If the square root wasn't there, it would be natural log. Is it flip up? It actually is flip up. Here's what it looks like. Integral of x, parentheses, 100 minus 36x squared, all to the negative 1/2 dx. You just flip the whole denominator up, and we're obviously doing two things in one. We're going from a radical to a rational exponent. We're changing the sign because we're flipping up. When you look at it from this perspective, isn't this a basic product where you say, hey, is the derivative of the inside the other factor? And so the derivative of the inside is negative 72x. The other factor is x. So this is very fixable simply by multiplying by a constant factor of negative 72. So as long as I multiply the outside by negative 1/72, I'm good. So this would end up being negative 1/72 times 100 minus 36x squared to the positive 1/2, all divided by 1/2, plus c. Of course, divided by 1/2 is really multiplying by 2, right? So this would give us negative 1/36 times that other stuff to the 1/2 plus c. That's the one we were talking about. Did that work out okay? Jeff? Yeah. Okay. Questions on that one? This is going well for you. This is a challenging exercise for sure. Brandon?
Why didn't you divide by 1/2?
So your power rule for antiderivatives,
Oh, I see.
you just divide by the new exponent. It's a 1/2. I usually just write it as times 2, but instead I wrote like that. Okay, our last one. Number 9. Okay, so number 9, it's not ln. Why is it not ln? Square root. Okay. Is it flip up? It's not flip up this time. You'd need the numerator would have to be something different, right? It'd have to have 2 terms. They have to be carefully designed for sure. And then that leads us to arcsine or arctangent. Which of those two is it definitely not? It's definitely not arctangent because of the square root. It's arcsine or arccosine perhaps, but let's go with arcsine, which is sort of standard. Oh, but wait, That does not look anything like a squared minus u squared, does it? What do I have to do? Yep, complete the square. One last chance here in class to do that. I'm going to write this as negative x squared minus 6x grouped plus 7. What is the one little minor detail step that I have to do before I start completing the square?
Take out the negative.
Get the negative factored out. Yep. So it'd be negative parentheses x squared plus 6x, still grouped together, plus 7. And what will I be adding to the inside of the parentheses? 9. The trick here, of course, is that I really did not just add 9 to the whole expression. I really subtracted it. So if I subtracted 9, I need to balance it by... There you go. That works too. So this gives me this plus 16 when I factor. And so I can come back over here now. I can get the 8 out of the numerator. And I get 1 over the square root of 16 minus quantity of x plus 3 squared. It's clearly arcsine. So what's my u prime? 1. Yep, and my a would be 4. So the numerator is only supposed to be u prime. So it's already set, right? It's what it's supposed to be. So I can go straight into 8 arcsine of u, which is x plus 3, over a, which is 4, plus c. A whole lot of antiderivatives, right?
It's a lot.
Yeah, we covered just about everything we could cover there in those 9 problems. Any questions? So keep in mind that later on when we get to a quiz over this material, any of these old antiderivatives are absolutely fair game. You should know them, right? Yeah.
For the AP test, how often will they give us these like complex?
How often? That's a really hard question to answer. I can guarantee you that at least a couple of them will show up in the multiple choice. The problem is you don't know which ones. So you kind of have to be ready for all of them. Yeah, could it be an arctangent or, some complete the square thing or a hard flip up? I have no idea. So you kind of have to be ready for it all. Guys, before we move on, any last questions on this section? Okay. So, hey guys, sit up please. Hey, this is going to be brand new for every single person in this room. So if you guys would flip over, we'll do a lot of 8.2 here. I don't think that we'll do every single example. We'll do at least a couple of them. So you may have heard me say, you may remember this, that whenever you're finding an antiderivative and the integrand is a product, it's potentially an issue, right? Potentially a challenge to deal with that. Just the same way if your integrand is a fraction, similarly challenging. And so, really, to be honest with you, we have learned exactly one way to deal with the antiderivative of a product, and that is Timmy messed up the chain rule. Right? If it doesn't sort of kind of fit that U substitution, Timmy messed it up thing, then to this point we'd be out of luck. So if you would peek ahead, let me show you stuff like this. What we'll be doing. Yes, ultraviolet voodoo. Take a look at number 1. Hey guys, you're going to want to focus here. You see how number 1 is a product? But it looks like nothing of any of the other products we've looked at. Number 2, similar. It's a product, but we've never seen anything like that. Number 3, number 4, 5 is a variation on number 4. These are all products, right? It's something times something for the integrand. But at this point, we have no idea how to deal with this. So that's what this is all about. So I'm going to be a little more specific than just saying a product. I'll say this is a valuable technique that is useful when integrating the product of a polynomial and a transcendental function. So if you remember transcendental functions, things like e to the x, natural log of x, cosine of x, stuff like that. Transcendental functions. You'll be able to see those. All right, so here is what we call integration by parts. Here's one of the rules. This is the rule we'll look at here in 8.2. The antiderivative of u times dv. So hopefully you can see this over here as a product where u is one factor, dv is the other factor. That's equal to uv minus the integral of v du. And I honestly, the thing up there is true of me still today. I just remember this, the right side is ultraviolet, like UV, right? Ultraviolet voodoo, I remember that it's minus because voodoo is bad, right? Minus, negative. Ultraviolet voodoo. So ultraviolet
That's the UVs.
voodoo. Or ultraviolet voodoo if you prefer, yes. So U times dV, so U is going to be some function in terms of x. No idea what that could be at this point. Some polynomial, some transcendental, could be a lot of stuff. dV is going to be the other one. So it's going to be U times dV is, literally it's the antiderivative of some product, where U is one factor and dV is the other factor.
So like x squared would be u, and then like ln x could be dv?
Are you referring to one of those other ones? Yeah, so what we'll do, we'll make U equal to one of the factors, and we'll make dV equal to the other factor.
Okay.
And which one you set up to be which does matter. And there's like sort of a loose rule about that, but there's one exception to that too. So we'll kind of look at that as well. So here's kind of the loose rules here. You can, and please don't get all bent out of shape about these two rules because they are kind of wordy. You can go back later and be like, okay, that actually does sort of make sense. You can let dV be the most complicated part of the integram that you could easily find the antiderivative of, then use the other stuff, or let U be the part that you can easily find the derivative of that results in a simpler function, and then dV would be the other stuff. I have a little more specific way of looking at it, but these rules are applicable for sure. But I thought I'd show you real quick where this comes from. So maybe off to the side here, you can write this down or you can just watch. It's totally up to you. Here we go. So basic proof. If I have two functions, we're going to call them u and v, and they're both in terms of x, and I've got u times v. So it's a product, right? So if I decided to do d dx of that product, what would I have to use? The product rule, right? Anytime you differentiate a product, you use your product rule. So it'd be 1d2 plus 2d1. Here it is. 1d2 plus 2d1. So d dx of u times v equals u times dv dx plus v times du dx. Basic product rule. 1d2 plus 2d1. What I'm going to do here at this point, just for sake of, and this is kind of why they do what they do here, just for sake of simplicity, I'm going to eliminate all the dx's, just so it's a little bit easier to write. So I'm going to write d of u times v equals u times dv plus v times du. It's the same thing. I just eliminated the dx's just so it's not so gangly. Because technically, dv would be dv dx and du would be du dx. We're just making it a little bit more simple to look at. I'm going to rearrange it a little bit. I am going to subtract. You can start to see this taking shape. I'm going to subtract voodoo. And now I'm going to anti-differentiate both sides. So as I anti-differentiate this and I anti-differentiate that, over here I just get u times dv. But on the left side, that first term isn't the antiderivative of a derivative, just FTC2. They cancel each other out, don't they?
Yeah.
So I end up with u times v minus the integral of v times du. There's my ultraviolet voodoo on the left. And here is my, oops, I forgot to copy that on down to the next line. Integral of u times dv. So as you can see, it's just a left to right rearrangement of what we just had. So it comes from the product rule. That's really all it is. Okay, so all this is really neat and everything. I'd be happy to field a question or two if you want, but I feel like it's way better to do an example or two, because you might at this point be thinking, oh my gosh, this looks really difficult. I think you'll find that it's not that bad. Okay? Remember, this is a key technique when you have the antiderivative of a product. And this is a little more of a broad technique. This will work on way more product or way more integrands that are products than what we've been able to do in the past. Okay? So, you guys ready to do an example or two? Okay. So let's take a look. Number one. So number 1 says antiderivative of x times sine of 6x dx. So what we would propose here is we would say this is that integral or antiderivative of u times dv. So it could go one of two ways. It could either be u times dv, or it could be u times dv. Right? So the x could be the u, or it could be the dv. The sine of 6x could be the dv or the u, and it could go either way. Now in this case, it's really going to matter. You're either going to end up with a nice clean answer, or you're going to end up with like this spiral of death where you just end up, it gets worse and worse and worse the further you go. And if you do end up in this spiral of death where you're just like, I'm never going to get an answer, you know what that means? Yeah, pick the wrong thing to be the u and the dv. You need to switch it around. So here's how I'm going to set this up. I'm going to come over here, and I'm going to write u equals, and I'm going to write dv equals, and notice how I wrote them on different lines. So I am, in just a second, I'm going to put v equals, and I'm going to put du equals. But to get this set up right, I need to fill this in and this in first. Okay? I got to establish what's my u and what's my dv. So I will take suggestions. And it is more or less a 50-50 shot. So the cool thing is, if you do it wrong, it's just the other way. Right? So it's not that pressure filled. Josh, what do you think?
X dx.
So which one goes where? So u is?
X dx.
I'm not going to put the dx in there.
Okay.
Because, and let me explain why. I'm not going to put the dx in there because in order for me to go from here to here, I need to do a derivative. And I don't want to do a derivative of something that already has a dx in there.
So do we basically just forget about the dx in this process?
We don't.
Oh.
So Josh says u equals x. dv then would have to be everything else. Sine of 6x dx. Okay, so let's see if Josh did this right. We'll find out here in a second. It was one of two ways. He picked one of them. See if it's good. In order to go from u to du, that's a derivative, right? Specifically, it's going to be a differential. So the differential of x would just be dx. So like 1 dx, if you will. Right? The derivative of x is 1, so it'd be 1 times dx. And then what about to go from dv to v? What am I going to have to do there? It's an integral, yeah. So to go from that, to process that step, what I really need to do is the antiderivative of sine of 6x dx. That's why the dx needs to be with the dv, so that you can have a valid antiderivative, or a valid integrand. So what is, by the way, the antiderivative of sine of 6x dx? There you go. So this is where, if you know your Timmy messed up the chain rule stuff, you can do this pretty quick. Negative 1/6. Oh, I'm not going to put the plus c yet. Negative 1/6 cosine of 6x. Okay. So far, so good. We started off with our u dv. You also need to know your du and your v to be able to fill this all the way out.
Wait, what about
What-
C?
We'll get the c in at the end,
Okay.
because the c is for the whole thing, not just one little piece.
Okay.
So let's do ultraviolet voodoo. Here we go. So ultraviolet would be this. Negative 1/6 x times cosine of 6x. There's my ultraviolet. Minus voodoo would be negative 1/6 cosine of 6x. And then the do in voodoo would just be dx. Make sense? Like earlier, Josh brought up a good point. He's like, do things just disappear? Do we ignore them? We really don't. Everything has its own little place. So the dx is still important here. Liz?
I'm just having trouble seeing like how the equation like fits into the formula. You know,
How the equation fits.
like I get the whole process of like the u and the du. And
No, so my proof earlier
and, like,
didn't click for you?
I just don't get like how to get from like x sine 6x to the equation.
Oh, so okay, hang on. So you're having a hard time with how you go from the original to getting all this filled out?
Or like parts of like the formula are, you know?
Okay. So let me see if I gotta.
I just don't oh wait, here's the real question. I just don't really understand like where, like what this is in the formula.
Yeah, sure. Okay, so here's that little formula I gave you earlier. So this is this.
Oh, okay.
And so that's why we put effort into finding what is the U and what's the dV. And we still haven't figured out if Josh picked the right way yet. We'll find that out here in a second. If you pick the wrong way, you'll just get that death spiral where things just get worse and worse and worse instead of clearing up. You'll be able to recognize that eventually. So then, Liz, what I've got, so like these two are the same. So then this and this are the same, and this and this are the same.
Okay, that was like exactly what my question was.
Okay. All right, awesome. So then, let's see, are you guys okay with doing this? It's really plus. Can't you just bring the negative out and a negative times a negative is positive?
Yeah.
Okay. So then let's see here. Maybe Josh didn't mess up. What is, if possible, well, maybe we should do this too. Let's get the 1/6 out of there. So if I'm going to look at the antiderivative of cosine of 6x, what does the other factor in the integrand have to be?
6.
Isn't the derivative of the inside a 6? So that means this has to be a 6 right here. But I can't just do that unless I also do what?
1/6.
Multiply by 1/6 on the outside. But look at this, is going to work out great. I think Josh picked the exact right thing because when I actually find my antiderivative, I get plus 136. What's the antiderivative of cosine? Sine. So it'd be 1/36 sine of 6x and plus c. Wow. So what if you had your doubts? What if you're like, no, that can't be right? What could you do to check this?
Take the derivative.
Yeah, you'd have a product rule. For the first term, you'd have a product rule with a chain in there. And the second one, you'd have a chain rule. You'd find out it works out perfectly. Really would. Believe it or not. Okay, so again, this is, for 90% of you, this is the first time you've seen something brand new in a while. Questions? Thought Liz's question was to the point for sure. What else? Colin?
So you actually need to take the antiderivatives as the integral
Of the voodoo. Yeah.
Okay.
Yeah, so like that's your voodoo right there. You actually
Leave it like that.
you got to finish it. Yeah.
So if you had chosen the U as what you did the V as,
Yeah.
it would you wouldn't be able to anti.
The x would spiral out of control. It would create more and more integration by parts.
Okay.
And so if you put the x over here, the antiderivative of x is 1/2 x squared, so it went up a degree.
Oh, so you want to put the X in the one that's going to integrate?
How is that?
And the one that's going to differentiate.
Or yeah.
In most cases, yes. In the vast majority of cases, I have one counterexample to that. You want to look at it?
Yeah, sure.
Here we go. Take a look at number 2. This will be our last one.
You had that one right.
And I'm only gonna show you a setup for this one. We'll finish these on Wednesday. Example number 2 says x squared ln of x. Sorry?
Do we have a test?
Or Thursday, I guess, is when we'll pick it up again. Sorry. I was thinking we had class tomorrow, but we don't. So I'll tell you what. We're not going to complete this one, so just watch. And we'll pick this one back up on Thursday. Just check this out. If I were to say u equals x squared and dv equals ln of x dx, this would be seemingly a very logical thing to do, right? Because finding du, what's du? 2x dx. So you're like, hey, this is looking pretty good, pretty easy. But now, for me to find my v, don't I have to anti-differentiate to get up there? Yeah. What's the antiderivative of ln of x? Be careful.
Oh, wait, never mind.
Isn't it tempting to say 1 over x?
You cannot.
But that's the derivative of ln of x, right? So what's the antiderivative of natural log of x? Hey, the fact that you're all saying, I don't know, is a good sign because you shouldn't know this yet. We don't know this yet. So this would be the one example. Well, the truth is, here's the answer to that question for those that care at this point. It's this.
What the heck?
How would you know? How would you know that? If you know how to do integration by parts, you can actually do that, which we'll get to that later.
We don't know that.
But this is, so Brandon, I wanted to get to this because this is the one time when you're not going to set your polynomial up to be your u. You would actually swap these two. Because natural log, right, exactly. It makes it a pretty easy derivative. And
Could you technically do it the other way if you knew the integration by parts?
it would create another integration by parts because you get that x ln of x times 2x now factor, and it would actually just spiral up and out of control. So no, yeah. Okay, so guys, as was mentioned a second ago, no, we go till, wait a minute. We go to 205. I don't know, maybe we'll do some of this. I don't know. But let's at least say this. Let's make this the priority. Your Wednesday class is Unit 3 test, which is up through Chapter 5. It's an early start. We don't have one next week, so don't worry about that. It'll be a while before we have an early start again. So show up at 7 if you want. Anywhere from 7 on, basically. Make sense?
And then do all these, all the complex integers.
That's in Chapter 5, yep.
Is it stuff, it's no new stuff, right? Stuff from last year?
Let's see here. In Chapter 5, was there...
Isn't there like that, oh wait.
There was one thing...
The thing, yeah.
yeah, hyperbolic sine and hyperbolic cosine.
Is there that on there?
This is the only time I would ever assess it. Jasmine. I'm a little lost. Oh, this is what we did this before. I think that's fine. Yep. Sorry, I had to think about it real quick. Okay. Well then, hey guys, let's finish this up. Let's do this one. Hey guys, let's finish together here. I'm always hesitant to say this. We might be able to find some counterexample to this. We very well could. So I'm going to say almost always, if one of your two factors is a natural log, make that your u. Okay, this is the one exception to the other rule that we talked about. So if your u is ln of x, what does your dv have to be?
1 over x.
No, your dv.
Oh, dv.
Has to be x squared dx. So I need to make this either u or dv, and then this would be everything else. Or this needs to be my u, and then this and this would be my dv. I've got to set it up. And like I said, you can set it up either way. And there's only 2 ways to do it, right? So if you mess it up and you're like, oh, this is horrible, just switch it around and it'll probably be a lot less horrible. Probably go pretty smooth. Okay, so if my u is ln of x, what's my du?
1 over x.
1 over x dx. And if my dv is x squared, what is my v? Very good. So once you have your v's and your du's and your dv's and your u's and all that set up, just a matter of setting up ultraviolet voodoo to finish this out. So it would be 1/3 x cubed natural log of x. That's ultraviolet. Minus, because it's bad, voodoo. So it'd be 1/3 x cubed times 1 over x dx. Why is this so much better? The x and the x cubed, they cancel out, don't they? So you end up with 1/3 x cubed natural log of x minus, it would be 1/3 integral of x squared dx. Final step. So a simple power rule at that point, and you're done. And again, if you have your doubts, and I challenge you guys, do the derivative of that, and you would find that that in fact actually is true. Good news is we'll pick this up again on Friday when I see you guys, or Thursday after we do our test on Wednesday. Have a good rest of your day.
So, extra practice due on Wednesday as well?